Hi, my name is Isabel, and I'll be presenting the introduction and executive summary of our project. So, our project focuses on designing and configuring a secure network infrastructure for a company that consists of four main departments, which are IT, customer service, human resource, and information security. So all these departments, they are connected to a centralized server room, and each department uses a different network topology based on its need. So through Keyscope Packet Tracer, we configure IP addressing, routing, device security, and remote access technologies. We also implemented security features such as encrypted roster password, SSH for secure remote management, and SNMP for monitoring network devices. So overall, this project helps to demonstrate how proper network design and cybersecurity controls can create a fast, efficient, and secure company network. Next, I will explain about the problem that this project aims to solve. So in today's digital environment, companies face serious cybersecurity challenges such as unauthorized access, data breaches, and system interruptions. Without proper protection, an organization information and services can easily be exposed to cyber threats. So in this scenario, the company needs a well-structured and secure network that can support all departments while preventing outside attacks. The problem we aim to solve is how to design a network that is not only functional and fast, but also protected with strong security measures. So by using different topology types, proper IP addressing, and secure configurations like SSH and encrypted password, our project ensures that the company has a reliable, scalable, and secure network environment.
Hi, my name is Damapisha, and I will be explaining the network topology used in each department. In this project, every department is assigned a different topology based on its operational needs and based on the questions given. We have implemented five different topology structures: a star topology for the IT department, a wireless tree topology for the CS department, a tree topology for the HR department, a ring mesh hybrid topology for the IS department, and a centralized topology for the server room. Each topology was chosen to ensure performance scalability and reliability for the specific environments. So, for IT department, we use star topology. In this design, all end devices connect directly to a central switch, which then connects to the router. This topology is used because it is simple, efficient, and very easy to manage. If a single PC or cables fails, the rest of the network continues running normally. It also simplifies troubleshooting because every device is individually connected to the switch. The STAS topology is suitable for IT because the department requires stable and structured connectivity for workstation, administrative tasks, and diagnosis. So, the CS department, we use wireless tree topology because this department mainly consists of wireless devices. In this structure, three wireless access points act as branching nodes, creating a tree-like hierarchy. Wireless devices such as laptops connects to the nearest access point, and all APs connect to the central switch. This topology was selected because customer service areas usually require mobility, flexibility, and coverage. A tree topology allows multiple APs to extend wireless range without overloading a single device. It also supports high device density, which is ideal for environments where many users rely on Wi-Fi at the same time. For the HR department, we implemented a tree topology. This is similar to a hierarchical structure in which multiple PCs burn out from a central switch through additional connection lines. A tree topology is ideal for HR because it allows clear device grouping and can easily be expanded by adding more branches if the department grows. It also reduces collision, domains, and organizes traffic flow more efficiently. Overall, this topology ensures that HR systems such as employees database and administrative tools function reliably without network congestion. The IS department used the most complex design, a ring mesh hybrid topology. In the ring portion, devices are connected in a circular pattern, allowing data to travel in multiple directions. This provides strong redundancy because if one link fails, data can still reach its destination through the opposite direction. We added mesh characteristics by connecting additional paths between some nodes. This increased fault tolerance and improved performance because multiple routes exist for data transmission. This hybrid topology is ideal for IS because this department handles important internet systems and may require high reliability and high uptime. Lastly, the server room use a centralized topology where critical devices, the DNS server, HTTP server, firewall, and core switch are all connected directly to the core router. This design ensures that the server room becomes the heart of the entire organization. All departments communicate with the server through this centralized router, enabling better traffic control and stronger security through firewall filtering. This structure also simplifies maintenance because all essential services and configuration are located in one place. Next, we're going to talk about IP addressing scheme. For the IP addressing scheme, each department is assigned its own 24 subnet. The CS department use 192.168.1.0, IT use 192.168.2.0, HR use 192.168.3.0, and IS use 192.168.4.0. Each department use the 0.254 address as the default gateway. All servers are placed in a separate subnet, which is 192.168.110.0/24. This is where the DNS server, HTTP server, firewall, and core router are located. To connect each department router to the server room router, we use small slash 30.2 point networks such as 10.0.1.0, 10.0.2.0, 10.0.3.0, and 10.0.4.0. This keep the routing structure and efficient. Overall, this addressing scheme organizes all department clearly, supports scalability, and ensure consistent gateway and device management across the network.
Hi, I'm Sydney, and let me explain the SSH configuration for the core switch and the core router in our network project. Starting with the core switch, this device connects all the servers in the server room to the rest of the network. It also links departmental routers. SSH is enabled on the core switch to allow secure remote management. Administrators must log in using a username and SSH password. All the commands are encrypted using RSA keys. This prevents unauthorized users from accessing the switch or intercepting sensitive configuration data. By enforcing SSH only access on the switch, we ensure that all remote management is safe and that the configuration changes cannot be compromised. Next, I will be explaining about the core router. Now, the core router acts as the central hub which connects all departmental routers and provides access to server resources. Like the switch, SSH is enabled to secure remote access. Administrators must enter a username and also a password, and the connection is encrypted with RSA keys. SSH on the core router protects critical routing information, firewall rules, and also the overall network flow. The router's VTY lines are configured to only allow SSH, blocking insecure telnet connections. In summary, SSH on both the core router and also the core switch creates a secure and encrypted gateway for network management. Only authorized administrators can access these devices, and all actions are protected from interception. This ensures the security and reliability of our central network infrastructure.
Assalamualaikum and hi everyone. My name is Raif Naufal. Now, I would like to explain the key configurations our team performed on the ASA firewall device based on the screenshots shown. First, we configured the inside interface, which is gigabit Internet 1.2. We assign it the IP address 192.168.10.1 with a subnet mask of 255.255.255.0 and ensure the interface was turned on with auto speed and duplex. This interface functions as the internal gateway for devices inside the network. Next, our team created and access control list name inside in. This ACL determines what types of traffic are allowed from the inside network. We permitted only essential services such as HTTP for web access, DNS for domain resolution, ICMP for connectivity testing, and BOOTP DHCP for automatic IP assignment. After setting up the SAL, we applied it to the inside interface using the access group command. This is an important step to make sure the SAL rules take effect on the interface. Finally, we save all configurations using write memory so that the settings remain active even after a reboot. In summary, these configurations help secure the inside network and ensure only necessary traffic flows through the firewall. Now, I would like to pass the floor to Livitha for ping testing. Thank you.
Hi, I'm Livitha. Now I'm going to explain about ping testing. As for this slide will be more to explanation, the next slide will be our demonstration. Full demonstration and clear picture of how ping testing works. So, as for the ping testing, I tested the main areas in our network which includes the core router, ITPC, HTTP server, ISPC and CSPC as for our demonstration. I check PC to router connectivity to make sure each department default gateway is working. Then I tested router to core router using the EIGRP link to confirm routing is active. Next, I verified router to router communication across all departments. I also tested PC to server connection for the DNS and HTTP service to confirm end-to-end access. Finally, I checked server to server connectivity in server room. All ping tests were successful, showing that the IP addressing, gateway, and routing were configured correctly. So the next slide will be the clear picture and clearer demonstration of how ping testing works for our topology.
My name is Ahmad Fawaz, so I will be presenting about the problem exists. So the first vulnerability is related to SNMP v2. SNMP v2 sends monitoring information without encryption, which means attackers can intercept data like router details, IP addresses, and the device performance. This is dangerous because it allows attacker to map the network and plan target attacks more easily. Second one is single point of failure in the server room router. This one router handles all DNS, web service, and communication between departments. If it fails, the entire network goes down, causing full downtime and major business interruption. So the third one is weak wireless security in CS department. Issues like weak password, MITM attacks, packet capture, or rogue access points can let attackers access the Wi-Fi network. Once inside, they can bypass router security and reach internal system, making the whole network vulnerable. So the next part is the solution. The first solution is securing SNMP. Since SNMP v2 sends monitoring data without encryption, the fix is to upgrade to SNMP v3, which adds encryption and authentication. We also use strong community string, restrict SNMP access only to the monitoring server using ACLS, and disable SNMP on any unused interfaces. This reduces the risk of attackers intercepting the device information. So for the second solution is preventing single point of failure. Because it is only the path for all departments, it becomes a single point of failure. To fix this, we add redundancy using HSRP or VRRP so a backup router can take over automatically. We also back up configuration regularly and add secondary uplinks and improve physical security in the server room. This ensures the entire network stays operational even if one device fails. So lastly, we improve wireless security in the CS department. We apply WPA2 or WPA3 encryption using strong password and change default AP credential and SSID. We also enable MAC filtering, reduce the broadcast range, and add wireless instruction detection and update password regularly. These steps help prevent unauthorized access and protect the internal network from wireless attacks. Thank you.
For our conclusion, our team successfully designed and implemented a network that meets all the required functional and security objectives. The centralized server room router allows smooth communication between the IT, CS, HR, and IS departments, supported by properly configured routers, switches, and end devices. All essential services such as static routing, SSH, SNMP, DNS, HTTP, and firewall filtering were set up correctly. Our connectivity test confirmed that every device could communicate consistently across the network, showing that the IP addressing and routing were accurate. We also applied key security measures, including firewall restrictions, secure remote access, wireless protection, and monitoring. Overall, this project demonstrates a functional, secure, and well structured network environment. That's all from us. Thank you so much.